We're still sticking with the same type of question, still solve algebraically, still check using a calculator. But this time we're going to have some more difficult exponents here. So the first thing I would do is I would clean this up as much as I could before putting it into any kind of logarithmic form. So I'm going to divide both sides by 2. So then I get 5x minus 3 equals 1700. Now I'm going to take log 10 of both sides. So we get 5x minus 3 equals log 1700. Then I'm going to use my power law. So I'm going to take this exponent. It's going to become my new coefficient. It should be in brackets. So x minus 3 log 5 equals log 1700. I could distribute the x and the negative 3 to this log, but because it's multiplication, I think it's actually easier just to divide both sides by log 5. So the calculator will do that no problem. I don't really like writing out decimals and stuff, so I'm just going to add 3 to both sides and put this in my calculator all at once. So then we get plus 3, and the calculator tells us that it's 7.6. You should check that with a graphing calculator. Our second question, very similar. Our first step is we're going to actually take the log of both sides. There's nothing I can really clean up because we got different bases. So I'll take log and 4 2x minus 1 equals the log of 3x plus 2. I'm going to use the power law on both sides. So I'm going to get 2x minus 1, make sure that's in brackets, log 4 equals x plus 2 and log 3. Now this one isn't just as simple as saying, hey, wouldn't it be nice if I could divide both sides by log 4? Because then I'm going to have an x still kind of hanging out in a weird spot. So instead I am going to distribute both of these. So I'm going to end up with 2x log 4 minus log 4 equals x times log 3 plus 2 log 3. Now we have x in 2 terms right now, so I want to put all the x terms to one side. So I'm going to go leave this 2x log 4 here. I'll subtract x log 3. And all the terms without an x in them, I'm going to add to the other side. So I'm going to add our log 4 to the other side. We still have this 2 log 3. Now that x is in both of these terms, I can factor the x out. So we're left with 2 log 4 minus log 3 equals 2 log 3 plus log 4. Now I can just divide both sides by 2 log 4 minus log 3 to determine what x is. So 2 log 3 plus log 4, and that's going to be all divided by 2 log 4 minus log 3. Because we decided to use the natural logarithm, this makes it no problem to put into a calculator. A disaster if you didn't though. So 2.14. Now before we complete this next question, I want to remind you there is more than one way to do some of these questions. Like maybe take the log of both sides, change of base, all sorts of different ways. So just because I'm doing it one way doesn't mean that's the only way to do it. Here I have log 2 being added, and it's equal to 3. So we got a constant again. I'm going to choose to put these two log 2's together. So we're going to go log 2. Because it's addition, that means it's actually multiplication inside of our log. So x plus 2. And on this right side, I need to make this a log with a base of 2. So then it's going to become 2 to the power of 3. Again, because when this base matches this base, the answer is whatever the exponent is, which in this case we want it to be 3. So now that I've got log 2 on both sides, I can get rid of the logarithms. So we're just left with, well, I'll distribute this already. So x squared plus 2x equals 2 cubed is 8. So then I'm going to subtract 8 from both sides. And then I need to factor this, and it becomes x plus 4 and x minus 2 equals 0. So therefore, x is equal to 2 and negative 4. Now we do need to check with the graphing calculator, or we could verify using left side, right side. And you're going to actually find that x is only equal to 2. It's not actually equal to 4. And that's based on using the calculator. You could do left side, right side, and substitute these in as well. For our next question, very, very similar. So here we have log 4, log 4, log 4. It seems like if I write the left side into a single logarithm, I can get rid of the logs. So I'll rewrite this as log 4. Now it's subtraction, which means I'm going to do a division between these. So I get x squared plus 1 all over 6 equals to log base 4 of 5. Now that they're both sides are one single logarithm and the bases match, I can get rid of them. So we're just x squared plus 1 over 6 equals 5. Multiply both sides by 6, so you get x squared plus 1 equals 30. And subtract 1 from both sides and take the square root. Now that is going to be a plus or minus square root of 29. Check on the calculator. Yep, sure enough, they're both answers this time.